Hello, my name is Vasant and I'll be explaining Spur gears today. So we're going to be doing problem 15.25 on page 669. Um, it says the 18-tooth pinion in figure 15.25 is driven 800 RPM by a motor that delivers 20 pounds per inch of torque. The gears provide a double reduction in speed with output taken from the 36-tooth gear. Both the 6-pitch and 9-pitch gears have a 25-degree pressure angle. Neglecting the small friction loss in the gears and bearings, determine the radial loads applied to countershaft bearings A and B. Sketch the countershaft as a free body in equilibrium. So to start this problem, we know our given. So we know that it's a small friction loss in gears, which is neglected. The motor torque is 20 pounds per inch, and the speed is 800 RPMs. We also need to make some assumptions in order to solve this problem. So the first assumption is that the gears mesh along their pitch circles, the shafts are parallel, bending of the countershaft is negligible, gears rigidly connected to their shafts. So the next part to solving this problem is the analysis portion. So to calculate the pitch diameter of the input pinion, we would use the formula N over P. So we would put 18 over 9, and then we're given 2 inches. So this is the pitch diameter of the input pinion. The next step to solving this problem would be calculating the planes. So we need to do both the vertical plane and the horizontal plane, but we're going to start off with the horizontal plane. So sigma MA is equal to 0. So we're going to do 20 pounds times the pitch diameter, which is 2 inches, plus 35.55 pounds times 10 inches, minus BH times 12 inches, which is equal to 0. So when we calculate BH from this, when you isolate the equation to finding BH, you're going to get that BH is equal to 32.96 pounds. So sigma F is equal to 0. So this is now going to be equal to 20 pounds plus 35.55 pounds minus 32.96 pounds minus AH, which is equal to 0. So to find AH, after you isolate the equation for AH, you're going to get 22.59. So now that we did the horizontal plane, we now have to calculate the values for the vertical plane. So just like the horizontal plane, sigma MA is equal to 0. Then we get 9.33 pounds times the pitch diameter, 2 inches, minus 16.58 times 10 inches, plus BV, which is what we are trying to solve for. So we're going to do BV times 12 inches, and we make this all equal to 0. So after isolating for BV, we got 12.26 pounds, and just like the horizontal equation, sigma F is equal to 0. This time we get negative 9.33 pounds plus 16.58 pounds minus 12.26 pounds plus AV, which is what we're isolating here for. And then we make this all equal to 0. And when we isolate for AV, we get 5.01 pounds. So the last part to solving this problem would be finding the bearing radial load for ARAD and BRAD. So for ARAD, we get 22.59 squared plus 5.01 squared, and we take the square root of that, and then we get 23.14 pounds. So 23.14 pounds is our ARAD for the bearing radial load, and for BRAD we get the square root of 32.96 squared plus 12.26 squared, and we get 35.17 pounds. So BRAD is equal to 35.17. So thank you all for watching my presentation, and I hope you learned something about Spur gears.